Okay, next bonus problem is, let's imagine we've got our 50mm column that we were dealing with previously. It's what would you say that is? 50, 100, 250? And it's nicely glued onto this surface. And I am going to apply a force eccentric, so we will set this so that it's halfway here. Okay, so we apply a force of make it something different to 50, 100. It's probably that'll be fine. 100 kilonewtons. Right. What's the maximum stress that's going to be applied in this case? So for this, we're going to need some of this stuff on the formula sheet. The question is what we're going to use. So we've been asked to do a stress problem, so we're going to use this or this, up to you. Let's go for this one here. So the maximum stress is going to be a combination of the direct stress. So we can work out what that is. That's the P. Okay, this has got radius of gyration, stuff like that in. So let's use this one here. Actually, I won't try and solve it in one go. Write out my terms before I put it into the equation. So it looks like the easy equation to use is the first one. So P is going to be 100,000 newtons. The area will be 0.05 squared. .5 times 10 to the minus 3 meters squared. The E. So the E is the distance away from the centroid. So this distance here. There we go, that's got an E. So that E is, so here to here is 50 millimeters. From here to here is 25 millimeters. And we're doing it so it's halfway. So half of 25 is 12.5. So that will be 0.0125 meters. The C is the distance where you're expecting it to bend. So by pushing it on this side, we would expect that the C, rather it's the distance from the neutral axis where you expect it to bend. So expecting it to bend in this side. So the C is this distance, where this is going to be my neutral axis where I'm expecting it to bend around. So C is 0.025 meters. The P, I know, oh sorry, I've got the I here. The I is going to be a 12th. B d to the power 3. Well, we're dealing with a square beam, so it's going to be d to the power 4. D is 0.05 to the power 4, and then divided by 12. So that equals 5.7083 times 10 to the minus 7, and that would be in meters to the power 4. So that's my I. P done E. So I'm going to need to know what my E is. So the E is 200, so that'd be 200 gigapascals. Okay, yeah. So decided to I'm going to use 200 gigapascals there. K. What about the K? So the question is, can you remember your K terms? This one has a fixed bottom, so that's the first one where the effective length is in effect double, so K equals 2. So that's my K. The L is going to be 0.25 meters. So that's millimeters there. Okay, so I've got the values. My calculator is set in decimals. Can I remember what a sec is? A sec is 1 over cosine. Yeah, it's 1 over cosine. Cosec is 1 over sine. Let's put all the numbers in and find what our maximum stress is. See if we get a sensible answer. So oops. 100,000 divided by A. So we've got 40 times 10 to the 6 plus times by E 0.0125 times by C 0.025 divided by I 5.2083 times 10 to the minus 7. Okay, what's that? So that's 60, it's bang on 60, divided by cos, and what we got here, so we got square root P, 100,000, E, 200, gigapascals. K is 2. Oops, don't want this to be in here. K is 2. L is 0.25. And on the bottom we have a 2. Right, so that's not a big number. Okay, so now I need to put this into radians. So basically we've got 1 there. I think I must have done something wrong. Yeah, I thought so. I forgot to multiply the I, didn't I? So this is wrong. Rub that out. Put the correct answer in there. So there we got 100,000 divided by 500 gigapascals. Got the I. So 5.5 times 10 to the minus 7. Times by 2. Times by 0.25 divided by 2. And that equals 0.2449. And now I'm suspecting I will get a sensible answer. I'm going to put that in cos. Okay, so at least we're not getting 0.999. So we're going to divide it by 0.97. Okay, so let's do 60 divided by answer. So that becomes 61.8. So add on the 40, and that will give me 101.85 megapascals. Okay, so that's that one done. We'll do one more bonus.